though.
And Brock Lesnar got kicked in the face by Usos, so he didn't get the win. That pisses me off when they do stuff like that.
What?
And those Usos, they got issues. They got issues. I don't like them.
Yeah.
Yeah, they got issues.
I'm surprised they're still with the tribal chief.
Say again?
I said I'm surprised they're still with the tribal chief. Didn't he beat up both of them?
Yeah. I don't know, but I fell asleep because I had to watch it like midnight. So I fell asleep. I didn't get to see who won between Big E and what's his name? McIntyre. I didn't get to see that. All right. So what did we go over last? Somebody tell me. Look in your. I can't remember what we went over last. So if somebody give me a reminder, because I went over 109, and every time I go over 109, it blanks me out what I went over in 110. So what was the last thing we went over?
We just went over the test.
We just went over the test.
Yeah.
Are you sure?
Pretty sure.
I thought we were doing. Okay. Well, let me look up right quick because
we haven't started anything new yet.
Okay. I thought. Okay, I got y'all mixed up with the 109. Okay, 109 we did start. Okay, let me look up the syllabus. And I think we go to logarithms next. I'm not sure. But I will look it up right now. And here we go. It's Friday. My brain's about fried anyway. Yeah, here we go. Rational functions. Okay, so y'all just finished. Oh, we did go through the test because I did. Okay, I remember doing long division. All right, so we don't go into logs until. Okay, so we're going to go with 5.1, 5.2, and 5.3. And it's not that much. That's why the test is so short. You get another short test on this one. So 5.1, 5.2, and 5.3. So I'm going to pick out the hot spots for you. 5.1, 5.2, and 5.3. And hit record. Can y'all see my screen, or did I share it yet? I guess I haven't. There we go. Y'all should be able to see it. Please give me a thumbs up. You can see my screen. Good. And record. And captions are on. All right, here we go. Now, as with chapter 4, I want you to be able to do anything with your calculator. This is another short. You ain't going to have another long one until we get into log. Okay, so this is another short test. And let me go ahead and show you the two parent graphs. There's two or three parent graphs here that you need to know. And that is the f of x is equal to 1 over x, which is a half a volcano. And then f of x is equal to 1 over x squared, which is your full volcano. Okay, so there are your two main graphs that you're going to be seeing a lot of. And I'm going to highlight those in green so you can actually see the graph. There's your two parent graphs. So, of course, I'm going to go ahead and go over this right quick. If you have f of x is equal to 1 over x minus 2 plus 3. Somebody tell me what the negative 2 is.
A right shift 2.
Good job. I was hoping somebody would remember all the stuff that we've been going over for the last 2 units. Right? Horizontal shift. And what is the +3?
Up 3.
Up 3. Good job. So the way you would write that, you would just make a new origin at, I'm going to use a light color, like, well, yellow. I'd make a new origin at 1, 2, and +3. 1, 2, 3. And there is my new origin. And then I would just draw, I'm going to do it in blue, something different. Just draw my, okay, so there is your new graph. So that right there is right up there. So be able to do that. That's pretty self-explanatory. I'm going to do one right here. This is your vertical shift up 3. So I don't want you to forget everything that you learned in the previous 2 units or 2 sections about vertical and horizontal shifts. They still apply. So if I give you one of these, f of x is equal to 1 over x plus 3 quantity squared minus 1. Then this is your horizontal shift of 3 to the what? 3 to the left, Hubert. Yeah, that's right. And 1 what? Down. So I go 3 to the left, 1 down. And this is my new origin. So I draw my volcano there now. So make sure you can do this on the calculator because this is going to be several test questions on chapter 5 right here. Make sure you can do horizontal and vertical shifts. Make sure you can do it on your calculator. Capiche? I'm not going to spend a lot of time on you graphing them like punching things in the calculator. I'm not going to do that, all right? I'm not going to do this. Make sure you can do 1 over x. There it is. And it's going to look like that. Domain is affected because it's a fraction. Remember, I told you, and this goes in red. This is a major deal. Domain is affected when you have a rational or a radical. Domain and range is affected with a rational or a radical. So after today, after chapter 5, you can't say all real numbers anymore because you can't have a 2 right here because 2 will give you a 0. You can't have 0 in the denominator. You can't have 0 in the denominator. And you can't take the even root of a what? Of a negative. So your domain is going to be affected with a rational or a radical. And we'll get to that when we get to the actual problems. Okay, let's go ahead and see if they give you, there's negative. I'm sorry. There's they're showing you a horizontal shift to the right, to the left. And we already talked about that. And here is your volcano. 1 over x squared. And they're going to give you, there's a horizontal shift of 1 to the right. We just talked about that. This line right here that it's approaching, see that dashed line? Write that down. That's called a asymptote. Write that down, asymptote. It's a dashed line that basically never touches your function. It represents where your domain is affected. So let's write that down. A vertical asymptote, and this is red, so it's important. A asymptote, and I don't even know how to spell it. Asymptote, T-O-T. I don't think that's right. I think it's supposed to get a P in here. I think. Okay? An asymptote is a imaginary line and usually is shown by being dashed that represents a number that cannot work in the function. Therefore, it shows where the domain and range are affected. And a vertical asymptote is one like this. That's a vertical asymptote because it's a vertical line. A horizontal asymptote is like that. And a function that you would have a vertical asymptote would be like the 1 over x. See? That's a vertical asymptote and a horizontal asymptote. And we're going to talk about how to calculate those in just a minute or two. So make sure you understand what an asymptote is. It's a line that shows you where the domain and range are affected. These are, you can have more than one asymptote. They're not going to show you until the next set of slides. So what do you need to be able to do in 5.1? You need to be able to graph on your calculator, or with a vertical or horizontal shift, you should be able to graph or sketch a graph in 5.1. That's not a big deal. All right, 5.2. That's where we're going to get into actually doing the vertical and horizontal asymptotes, which is not a lot of algebra. It's just a little bit. There's the asymptote there. Talking about vertical and horizontal. And I want to get to the test. Where are the tests? Hold on, I'm getting there. Where's the test? Okay, there's the vertical asymptote, but I don't want that. There we go. All right, write this down. I want you to write this one down. I'm going to give you the Hubertism definition. Okay. First of all, let me back up. There we go. Vertical asymptote. How do you find a vertical asymptote? You set the denominator or the radicand equal to 0. That's it. So I'm going to go down here and I'm going to write everything while you're writing. So vertical asymptote, we're going to call it VA because I'm not writing that 15,000 times. The vertical asymptote, you set the denominator or radicand, what's under the radical, equal to what? 0. Because you can't have 0 in the denominator and you can't have a negative in an even what? An even index radical. All right, what about a horizontal asymptote? Well, there's 3 tests for a horizontal asymptote. Number 1, if the numerator has a lesser degree than the denominator. If numerator has a lesser degree than the denominator. Then the horizontal asymptote will always be the x-axis. If the numerator is equal to the degree of the denominator, then it's just going to be the coefficients. And 3, if the degree of the numerator is higher than the degree of the denominator, then you're going to use long division. Right here, if the degree of the degree is exactly 1 greater than the denominator, there will be an oblique asymptote. To find it, should be divide. Okay? So that's how you find out if you got a vertical or horizontal asymptote. So here is my rendition. To find out if you've got a vertical asymptote, set the denominator or the radicand equal to 0. Horizontal asymptote. If the numerator has a lesser degree than the denominator, then the x-axis will always be your horizontal asymptote. If they are equal, if the degrees of the numerator and denominator are equal, then the coefficient will be the horizontal asymptote. And if the degree of the numerator is higher than the degree of the denominator, use long division. And that's usually by 1. So I'm going to put right here by 1. Then you use long division. All right, I won't let you write that down because you'll see it after we do a couple of examples. This is the only algebra right now that we're going to be doing. The only algebra really is right here. So we're not doing any algebra yet. This is just note-taking and sketching and graphing on the calculator. This is our first algebra right here. So I'm going to go back to the thing here, and I'm going to let you see some examples. Come on, where's an example? I'll get into all this later. Just give me the, okay, here we go. Write that example down. So f of x is equal to x plus 1 over 2x squared plus 5x minus 3. Now, right now, you can't tell me a whole lot about it because you got a fraction and you're not familiar with fractions. So, but it's going to have a volcano look to it because you got the 2x squared on the bottom. So it's going to have a volcano type look to it. May not look as good as the volcano of x squared, but it'll have some look to it. You also got a y-intercept of negative 1/3. You know that just by mentally plugging in. Y-intercept is equal to 0, negative 1/3, or negative 1/3. You know that by mentally plugging in a 0. The only thing left is that is negative 1/3. So you at least know the y-intercept. Look at the degree of the numerator and the denominator. And I'm going to do that in red. So I'm going to go here. And here is the degree of the numerator. And here is the degree of the denominator. So somebody tell me, what can you tell me from the degree of the numerator and the degree of the denominator? The degree of denominator, parentheses, 2, is greater than the degree of the numerator, which is 1. Therefore, what happens when the degree of the numerator is less than the degree of the denominator? I want somebody to read that for me.
X-axis.
Thank you. I know that hurt, but okay. So that means that the x-axis is your horizontal asymptote. Now we're going to set that denominator equal to 0. 2x squared plus 5x minus 3 is equal to 0. To find our x-intercepts, if you want to, you can use complete the square. You could try to factor. You might be able to get it. Let's try it. 1x, 2x. Let's see, we have a 3 right here and a 1 right here. We should be able to get 5, but the negative, and that's not working. So what if I put a 2 right here? I'm sorry, a 1 right here. I'm sorry, a 3. Yeah, a 3 right here. That'll work. And a 1 right there. This needs to be positive, so 6 has to be positive. This is unlike, so if this is positive, this is negative. Equal to 0. X plus 3 is equal to 0. 2x minus 1 is equal to 0. So negative 3 is an x-intercept. I'm sorry, is a vertical asymptote. And 2x is equal to 1. 1/2 is equal to a vertical asymptote. So we've got a graph. The horizontal asymptote is this, the x-axis. And we got 2 vertical asymptotes. Vertical asymptote at negative 3. and 1/2. So our vertical asymptotes, we'll color them yellow. And we don't know what the function looks like, so we might need to graph it on the graphing calculator, but it might have a U here and something over here. I don't have any idea what it'll look like, but it might look something like this. It can't touch the yellow lines. Okay, that's one. I don't know if that it could be up here since it's x squared. It could be like this. And then have this on the bottom. Okay, so it could be this, this, and this, or it could be this, this, and this. So let's graph it. Well, it'd be better if I just show it to you in the slide. Okay, so let's see. Excuse me. Okay, there's the y-intercept. The x-intercept. We found that. What did they get for x-intercept? Oh, okay, they solved it by just multiplying both sides by, okay, that's fine, you can do that. Okay. There we go. Okay, it looks like that. All right, so I'm a little bit off. So mine, there we go. And that. And that. All right, let's try this one. I'd like to at least get through 9.2 or 5.2. F of x is equal to 2x plus 1 over x minus what? 3. In this case, you know that the y-intercept is negative 1/3 again. The x-intercept, you plug in 0 for y, solve both sides, you get 1/2. I didn't show you that a while ago. X-intercept be what? Let's see. 0 is equal to 2x plus 1 be negative 1/2. And what do we notice about the degree of the numerator and the degree of the denominator? Degree of the numerator is what? 1. What's the degree of the denominator? They're equal. The degree of the numerator is equal to the degree of the denominator. Therefore, the vertical asymptote, the vertical asymptote is equal to the coefficient of the function. And that's going to be 2 over what? 1. So your horizontal asymptote. Your horizontal asymptote is equal to 2 over 1, which is equal to 2. And your vertical asymptote is x minus 3 is equal to 0. And x is equal to 3. So there's a vertical asymptote at x is equal to 3. So if you were going to sketch this, 1, 2, 3, there's your vertical asymptote. Your horizontal asymptote is at 2. And that's what it looks like. You got a y-intercept at 0, negative 1/3. You got an x-intercept at 3. Can't have it at 3. Wait a minute. No, I'm sorry. Negative 1/2. Woo. X-intercept at negative 1/2, which would be right about there. So let's look at this one and see what it looks like. There it is. And of course, you can use your calculator to punch that in. All right. That's the same type. The degree is the same. Well, I was going to try to find you one that you do long division. There's one you use long division right there. So write that one down, and that's your example of long division. Or just division. This one would be long division. F of x is equal to x squared plus 1 over x minus 2. Well, since the degree of the numerator is higher than the degree of the denominator, you're going to use long division. And we know that the y-intercept is negative 1/2. We know the x-intercept, well, we multiply both sides, square root of positive negative 1. Positive and negative 1 is your x-intercepts. And since this, we're going to use long division, so that's x minus 2 into x squared plus 0x plus 1. Excuse me. X will go into x times. X times x is x. X times 2 is negative 2x. You always subtract. Makes this into a negative. It goes out, which is supposed to. And 0 minus 2x, well, that makes that a positive. So that's going to be 2x. And the 1 comes down to help out. And x will go into 2x 2 times. 2 times x is 2x. 2 times negative 2 is negative 4. Always subtract. That goes out, and you've got a remainder of 5, which I don't care about that, because this is your oblique asymptote. Okay, so let's sketch it. Oh, we also got a horizontal asymptote, a vertical asymptote at 2, at +2. Excuse me. Vertical asymptote equals 2. So if I want to graph this or sketch it, I know I've got a vertical asymptote at 2 and a horizontal asymptote or an oblique asymptote x plus 2. 1 to 1, 1 to 1, 1 to 1. I got an x-intercept or y-intercept of -1/2 and a x-intercept at +1 and at -1, which is right in here. I think it looks something like this. But I may be wrong. So let's see what it looks like. Yep. That's it. So in 5.2, I want you to be able to do 3 things. I want you to be able to graph, of course, graph or sketch. I want you to be able to find the vertical asymptote and the horizontal asymptote and the x and y intercepts. And let's look at the last section. I know I'm running out of time, but I just wanted to look for the last section right quick. And I can't find it. Where is it? There it is. The last section, and then I'll call the roll, is, come on, you can do it. That's your rationals. I mean, your radicals. And this is where we solve an equation. So we're going to go over 5.3 when y'all get back from break. So anyway, let me get out of that and go here, turn off the share. And turn off the recording and turn off